Hi everyone, welcome to my channel. I'm RockyBhatia, a passionate system designer working with Adobe as an architect. So in this video, I'm going to share a well-grounded strategies, a practical tips, of course, a master template to crack any system design. A strong foundation of system design is very much required to have a bright career in this tech industry for multiple reasons. First of all, it's a must skill. You cannot crack a good company without a solid foundation of system design. It's not about cracking the company. Even to reach a highly demanded roles like software architect, system architect, CTO, you need to have a strong foundation in system design. And if you are aspiring to run a startup or working in a startup, this is a must skill. Building a scalable and reliable tech product is a foundation for a successful startup. And there are other multiple reasons. This is a highly demanding skill in our tech, where a lot of companies are looking for such individuals who can design and build the complex system as per their user needs. Therefore, the foundation of system design is a must in our career. Nobody becomes a system design expert overnightly. It's a journey that takes time. There are a lot of skills that are required. So in later part of the video, based on my experience, I will share a few practical tips how to start your journey and how you can hone these skills in a practical way. But before that, I would like to cover that how to approach any system design problem. Let us try to understand a very effective but easy approach to crack any system design interview or to approach any system design otherwise also. So the very first step is understand the requirement. So whatever the system that we're going to build, we should be able to understand the functional requirement, non-functional requirement, the features that we should have in that system. Let's say somebody would ask you that we want to build a system like YouTube. Now you should pause this video and try to jot down some points, or maybe you can think for a moment and you can come up with few points related to high level requirements and of course the non-functional requirement. So high level requirements could be user should be able to upload the video, user should be able to play the video. In terms of conversation, they should be able to like it, they should be able to comment it, user profile management should be there in terms of registration, watching history, everything. Recommendation services there in terms of advertiser, they should be able to run the ad and other aspects. So you have to clarify the requirement. The first thing is you might not require all the features. So you want to maybe focus on the uploading or play part, or maybe like or comment, not on the recommendation, but the requirement should be very clear. Now coming to non-functional requirements. So we know YouTube has a huge user base. So non-functional requirement in terms of scalability, as we know, YouTube is growing very fast. A lot of new users are coming and a lot of new creators are coming. So a system should be highly scalable. System should be reliable. Like there is no scope that it should go down. Millions of users are watching. Other aspects related to consistency, availability. Now there could be other constraints in terms of like latency should be very low in terms of sense, and we should be very clear in terms of whether our system is read heavy or write heavy. Like in case of YouTube, we know it's a read heavy, and there are other constraints in terms of let's say we want to choose consistency or availability. In case of YouTube, it is choosing availability. Now you're watching my video. For you, the seamless experience is the video should run smoothly. So it will not hardly make any difference that if you're not getting a real-time updates in terms of my likes or comments, so it may get delayed. So YouTube put a weightage on availability over a consistency to have a seamless experience. So we should like think in terms of what are our non-functional requirement as well. So very first thing is requirement should be very clear what exactly that we want to build. Now the second step is we need to understand the users. When we say users, we need to understand who are going to use this system, what are their types, their different locations, how they are going to interact with the system, like different devices. If you have to think about different users, what are the different scenarios you can think of, and what are the different things that you should consider in this step. Now when it comes to users, we know there could be administrator, viewer, content uploaders, like content creators, those who run the advertisers. Now in terms of their viewing experience, we might have to think what are the different devices they might use. They might use web interface, they might use mobile devices, different browsers. Is there any peak load like which we have to consider, where we know that in evening or in weekends where the traffic is on the higher side, because people have leisure time and they would like to spend on that in YouTube. So these are the very basic things. Now, when you know that we have a global environment, so you'll think about the CDN. So when we know that we have a different devices to connect with YouTube, so you'll think about all the touch points. once you have requirements, once you have thoroughly understand about the user, then the third important step is about the thinking about the data model and storage. This is very important step. No system can run without storing information database. That information could be used to interact with the system. That information could be used to run any ML server. That information could be used to build any recommendation. But this, we need to store the data. We need to process the data. We need to interact with databases. We need to interact with systems. So data model and data storage is very much important. Now, if you have to think about YouTube, again, you can take a pause and think about, if you have to think about databases or a storage, what are the factors that you need to consider? You may consider that what kind of data that we have to store. First, from user perspective, their profiles. From video perspective, video metadata, thumbnail, actual video file. From conversation perspective, likes, comments. And from, the data modeling perspective, like one user could like many videos, and in one video we could have multiple likes, their subscription. So a lot of things are there. So we have to think in that way. Let's say in case of YouTube, so we might want to maybe maintain a user profile in RDBMS. Of course, a sharding is required. So we need to also understand the user base or the scale that we are dealing with. Do we need a layer in which maybe transaction is involved, a payment is involved? So maybe we would like to go with the RDBMS system, which is more reliable in that case. Are we talking about the scale where, let's say, about like and comment? So for that one, maybe we would go for a NoSQL system like MongoDB or Cassandra, where scalability is not a problem, and then we could have a flexible schema, something like that. We might need a graph based model where we want to interact with multiple touch points and we want to come up with something which could give us a more insight. Similarly, from storage point of view, we want to store an actual video file. So that video file could be stored in a blob, in an S3, or any distributed storage, or we could place that information in CDN as well. So we need to think about all these things in terms of data modeling. What are the different options and which option I should choose and why? So once we have built the data model, now the next step is APIs. APIs are very important. So two A's that is gonna rule the world is artificial intelligence and APIs. They are everywhere. So we need to come up with set of APIs which are required in this system. Now there could be user APIs in terms of their creation, registration, authentication, video API in terms of upload, view, conversation APIs like share, like, comment, recommendations APIs, monetization API in terms of premium subscription or running the ad. So there could be different set of APIs which would be required. So during this phase, we also have to think in terms of their interaction, in terms of like which protocol they're going to use. Are they going to use REST, SOAP, GraphQL, which and why? So we should be very clear. And once we are done with this API, so next step is, now we need to come up with high level components which are required for building the system. For example, databases are there, application servers are there, load balancers are there, gateways are there, CDNs are there. So similarly, we need to come up with a list. So once you have clarity, okay, these are the systems are required for this feature, for recommendation. Let's say you want to do analytics service, so you know, or if you have a real-time streaming solution, you know that you need a messaging queue. If you have to run any analytics service, you know you need to have a Spark. If you want to run and you know the traffics and you know that users are geographically located, so you need load balancer, you need CDNs. So you might need a cache layer also, so that you can avoid a lot of calls on databases. If you have to come up with a monitoring, then maybe you will come up with Prometheus or similar kind of things. You will capture a lot of matrices to make sure the system is running fine or not. So that way, at least you should be very clear that these are the high level components that are required for building my system. So once you are done with this thing, so the next part is you have components. Now you have to fit all these components in a layer which we call architecture. So in that, now you would draw a flow where a user who is interacting with the system, this would be my user interface, and then maybe here my load balancer will come into picture. Now this is my service, this is my one service, this is my second service, this service is interacting with my database, this service is interacting with my file system, this service is interacting through this particular protocol, and this service is interacting with this particular layer. So you should have that clarity. That clarity We brought it by following some steps. So once you have that, high level architecture in terms of like, these are the components, this is how it works, these are the high level services, and you also have that clarity in terms of what are the architecture pattern that we are going to follow. Are we going to use microservice pattern? Are we going to use a master slave architecture? Are we going to use any other architecture? So you should have that clarity that this is a system, and high level of maybe couple of technologies also, that this is how we are going to build that one. And you should also be very comfortable in terms of other things also, that if we are running a lot of things and we want to automate, do I need containers? Do I need Kubernetes environment? Are we going to run this anything on the cloud? What is the different service that is required? So once you have this clarity, and then the next step which is there, then you can go to the low level design. So when we say low level design, so in the low level design, maybe you can focus on each of the service. For example, we had covered a lot of services, user management services there, upload services there, and other services are there. Suppose you have to think now about each service, or let's take example of upload service. So we know when a user will upload, what are the different functionalities, or what are the other things which would be involved. So once he will upload, maybe we'll make sure that user is authenticated, then he should be able to do that one. When a video is uploading, we need to extract the metadata for that video, and then we need to store that information in some database. We need to place that file, actual video file, in some distributed storage location. We need to make sure that we are applying compression so that it should take less space. Similarly, we want to make sure that user is notified once a upload was there. So you could think like in each of service, then further we have a lot of other functionality, and then we need to come up with within that particular service, we also think that how they are able to communicate with each other, what would be their different API level contracts would be there, and what is the data format they are going to support. So there are a lot of other things, but the main crux is all about following this 7-step strategy. First, we need to come up with the requirement. Second step is we need to be very clear about the users. Third one is we need to come up with a data model. Fourth is API. Fifth is high level components which are being used. Sixth is coming with the high level architecture, going deep. And the seventh is coming with the low level design. By following this approach, we can solve any kind of system design problem. I would like to share like few tips that you can try. If you're totally new in this game, you should try to build a strong foundation in some of the components. First, you should have a basic understanding about load balancers, application gateways, DNS, CDN, different NoSQL databases, different between SQL and NoSQL, CAP theorem, different messaging protocols, messaging queues. Basic understanding about these components which are very much required to build any system. Apart from this thing, now build your knowledge around different architecture pattern in terms of microservices, client servers, event driven, like other patterns are also there. So you should be very comfortable that which pattern is being followed and which particular real life example that particular pattern is being adopted. Then you should thoroughly like follow some of the engineering blocks from Netflix, Adobe, Airbnb, Uber, and other good companies. So they share their best practices, and then you'll come up with the real world problems that they face, and then how they came up with the solutions. You should be very curious about the system that you are and the system around you, how that system is working. You will try on multiple things, you will fail, more and more you will try, and more knowledge you will gain. So it's not about that one can become an expert overnight. It's a journey that will take some time. So once you have nailed it, trust me, it will definitely pay you in long run. In the future videos, we'll cover a lot of components that we have discussed in details, and a lot of system design things like Instagram, Facebook, Twitter, YouTube, and other major system design problems that we come across. Thank you so much for listening me. Have a great day. I'm signing off. Thank you.